All right, welcome back. Training Module 13.1, Fahrion Precision Collet System. I'm your trainer, Edwin Tunney, Training and Technical Specialist for Horn USA Incorporated. During this module, we will review the Fahrion Centro P Premium system, talk about some of the value-added features, success in the market, and how to apply. From an overview standpoint, if you're used to the Centro P collet system of the past, where you had a holder, you had a front nut and a collet all treated as separate items, the Centro P Premium is a vast upgrade to that. It's divided into three separate systems: the MPC, Mini Precision Chuck, the DPC, the Dynamic Precision Chuck, the UPC, the Ultra Power Chuck. The MPC is designed to fit into tight spaces on higher speed spindles. The Dynamic Precision Chuck is designed for high speed operation on low stability machines. And the Ultra Power Chuck is high performance on stable and dynamic machines. A choice of back ends, so CAT 4050, HSK-A 63 and 100, HSK-E 25, 32, and 40, PSC, which is a polygonal shank, 63, SK 4050, BT 30, 40, 50, and cylindrical diameters 10 and 16. The addition of this system, in addition to combining the front nut and the holder, all components are coated with the Fahrion Protect system, so the anti-corrosion system from Fahrion. The MPC system is the first one we'll talk about, the Mini Precision Chuck. So you have a collet series from 8 all the way to 16. You have collet types HP, which is the high performance chuck. You have B type collets, which are a 10 micron collet with some collapse. The HPD and BD, which are the high performance seal collets, and the B size or B grade collet with seals. The HPDD, which is the high performance collet sealed and jet holes. The GBD and GBDD, which are the tap collets, both the standard ISO drive tap collet and a tap collet with sealed jet holes, sealed and with jet holes. The collet sizes for the MPC system range from 1/16 all the way to 3/8, and then ER system 8 all the way to 16. If you look at the chart here, it kind of tells the story of the purpose of the MPC is really to get down into tight contours and get into features of a part. So you have interference contours are maximized. The removal rate also maximized. Performance of the machine doesn't have to be very high. You can use these on any number of machining centers or lathes. The machine speed tends to be maximized since you're talking about smaller diameter end mills. The stability doesn't have to be a super stable machine. The pull-out force is on the lower end of the spectrum when it comes to comparing it to an MPC, a DPC, or a UPC system. The next system to talk about is the Dynamic Precision Chuck, which is the DPC system. This is basically high-speed operations on low stability machines. So think of a mindset of high-speed machining. You have collet series from 16 to 40. You have sizes from 1/16 all the way to 1 inch. You also have the same collet lineup, the HP, the B, the HPD, the BD, the HPDD, the GBD, and the GBDD. So HP is the performance collet, B is the collapsible B grade collet or 10 micron collet. The HPD is the sealed high performance collet. The BD is the sealed 10 micron. The HPDD is the sealed collet with jet holes. The GBD is a tap collet with seals, and then the GBDD is the tap collet with jet holes and sealed. From the chart, you can see that everything is kind of middle of the road on the DPC when comparing to the other systems, to the MPC and the UPC. So the removal rate is about average. The interference contours, this still can reach into tight places in the component. The performance machine doesn't have to be a high performance machine, but you don't really want unstable machines with these, usually with high speed machining. The machine speed is kind of average, the stability is average, and the pull-out force on this collet series or collet system is about average. Again, all protected with Fahrion Protect. The last system here is the UPC. So this is the ultra power chuck. When you think about UPC, this is for high removal rate, aggressive roughing type operations. That's why you see the collet series is 32 and 40. Same collet types, sizes, 1/8 inch all the way to 1 inch on the 40 series. And you can see the removal rate is maximized. The performance of the machine to get the best out of the collet system, and honestly, your tool needs to be very stable. The speed doesn't need to be too high. You're talking usually about roughing tools, pocketing, those kinds of operations. The stability needs to be a stable machine. Pull-out force on these is maximized, both from the standpoint of the size of the system and then also the addition of the WD collet. So the WD collet is a captive collet system for a standard Weldon flat that will actually lock the tool in and not allow it to pull out. So that's why the pull-out force is maximized. If we stay along the lines of the UPC collet and compare it to conventional power chuck, many of you may have used conventional power chucks in the past. I myself have as well. The gripping force tends to be pretty good with these type of collets. But if you cross-section one of these, the biggest problem really is a weaker cross-section. So if you compare the cross-section of a common sort of roll mill chuck or a power chuck versus the Fahrion power chuck, you can see a dramatic difference in the cross-sectional area of material at the base of the holder. Also, you don't have mechanical locking with this system. So there's no mechanical locking to prevent the end mill from sliding out. So it's pure reliance on the clamping force. They usually have, because of the weaker cross-section, lower radial load capability than the beefier Fahrion UPC power chuck. So the benefits of the power chuck, the UPC power chuck, are it's better protected against tool creep, both axially and radially, increased cross-section, and then shorter length. So we know from machining, especially solid tools, that every millimeter of overhang matters to get the maximum performance of the tool. Additionally, comparing the two different types of systems, if you compare an ER type system with a Fahrion precision collet, they use in the ER system, they use lower quality case hardened ball bearings. They're conventional deep groove bearings. That's why when you see these systems, when you tighten, it will kind of start to tighten up, and then it'll tighten up a little more. And then when you loosen, you also feel that resistance. So that's a result of having these deep groove ball bearings. Half the number of bearings compared to the UPC chuck, and then they're case hardened, so they can oblong over time and create some error and reduce clamping force. The UPC, on the other hand, has fully hardened bearings. They're made from a higher quality steel. They're angular contact, so that reduces the friction during clamping and unclamping. And friction during clamping is going to lead to inaccuracy. The smaller diameter bearings also allow less stress per bearing, so it's a little bit longer life and better dampening of the system. So we talked about the three chucks. Now let's talk about the collets. So the collets themselves are the same collets that you're used to if you've used the Fahrion in the past, with the addition of the Fahrion Protect as standard. So if you look across the different series, what we talked about in the beginning, the high performance collets are 2-micron collets. So a 2-micron means that it is a 2-micron run out. So when you clamp on this at, I think the maximum 100 millimeter out, or 3 times diameter, when you measure the concentricity of the tool, it's going to be within 2 micron. The HPD collet is same high performance 2 micron with seals, and then also with seals and jet holes. Then you have the tap collets. One thing to note with the tap collets is be sure of your taps. You might have, let's say, an M5 by 0.8 tap, but make sure the back end is an ISO square drive and not an ANSI or an inch standard. These collets are designed for ISO standard square drive. The WD collet, as mentioned, locking the tool in place. The B collets, so the B collets are 10 micron collets and 5 micron. So at the ER8 size, they're 10. At the 11 to the 40, they're 5. So still very good quality. And they do have some collapse, which we'll talk about in a moment. And then you also have the tap drive with seals, the BD collets for internal coolant. So all the collets are protected with Fahrion Protect. This is a little view of collets that were treated. The one on the right is treated with Fahrion Protect. The one on the left is not. And as this corrosion starts to happen on a collet, you lose some of your accuracy and your holding power. So the dirt, dust, and everything can build up on that corrosion and cause inaccuracy. Also causes problems with the grip of that collet. So Fahrion Protect is definitely worth the investment. Always check the compatibility of the collet series. Just a few exceptions here. The WD collet is primarily made for the ultra power chuck. It's kind of a no-go with the mini precision chuck because it just doesn't fit on the smaller systems, and it's on the dynamic power chuck it's limited in its use. WD collets are generally recommended for the UPC chuck and nothing else. Match the shank tolerance to the collet series applied. You may have an instance where the shank, for some reason, is not an ISO standard. It could be not a H8, but could be some other dimension, and that's where you would come in with a B size collet. Everything else, though, with standard sort of back end dimensions, H10, H8, those are going to work in the high performance collets. The B size collets do have some collapse, but be careful, they don't have a lot, 0.5 to 1, depending on the system size. So as you go up in size to the 40 system, you get more collapse. The tap collets, as mentioned, those are ISO square drive. So that's the overview of the system. Now let's talk about the features. So the features of the collet: best in class concentricity, 2 or 4 micron, depending on the system size. Fahrion Protect, anti-corrosion, low collapse for higher gripping force. So the tighter you hold this diameter to a nominal, the more gripping force you're going to have. So you're giving up a little flexibility, but you're gaining back some gripping force. They're highly polished, and the high polish actually has a function. It's not just pretty. One, it provides a good basis for the Fahrion Protect. And then 2, it also helps the collet lock without error during seating of the collet. So as this is tightened, it doesn't twist, and it tends to be more accurate by having that surface with less friction. The captive welding system, as you can see, can lock in those welding tools. It's compatible with standard ER collet chucks. So if you do have other ER collet chucks, if you have ER collet chucks floating around, then these will work. On the Fahrion, on the HP side, you need to remove this little plastic ring. The plastic ring just serves as an indicator that this is a high precision collet. You also have coolant jets and sealed collets. So where you can't get in with coolant lines, maybe the coolant line, the coolant flow from the external coolant is obstructed by the part features or fixturing, you can get in there with a jet collet and get the part cool. On the holder side of things, taper to taper concentricity is 1 or 2 micron, so very, very tightly held. The thread system for the front nut is different than conventional ER. It is a 30-degree trapezoidal thread, which is a very fast, since it's a very coarse pitch thread. It's a very fast thread and also very rigid. You have guide areas on the front nut so that you have a very smooth clamping of the system. You have 0 standoff of the collet. So you can maybe see here, the collet itself doesn't protrude from the base holder. It sits right at the level. So that's why you don't have a collapse with the high performance collets, but it also makes the tool shorter and also gives you better clamping force. In addition to all these features, you also have safety clamping system with torque limiting wrench. So you have, I think, about 6 different wrenches to fit all the different types of front nuts, and those have a torque limiting function so that you get the best use out of your tool. You don't over tighten the system and create damage to the collet or the front nut or the holder. There's a big difference in collet systems. If you look at a Centro P system versus say a hydraulic system, both have near comparable concentricity, I believe. For the most part, hydraulic systems are probably around the 4 micron mark with concentricity, where these collets are 2. But the problem is the hydraulic system here is really tightest at the center, and then you lose clamping force towards the end of the tool. So it's just not as rigid of a clamping system. Then if you compare this to an ER system, so the blue line here is an ER32 collet. and the Centro P 32 collet compared in red. So at, let's say, 12 millimeter or half-inch collet, you're looking at 75 Newton meters of clamping force versus the Centro P is a little bit over 150. So almost a little more than double the clamping force of a conventional ER collet system. Additional sort of benefits, features and benefits of the Fahrion system is there are fewer slots. So there's just the right amount of slots to give some dampening of the collet system. So it's better dampening than you would find maybe with a shrink fit system. The outside diameter matches the clamping nut. The tightening torque of the clamping nut actually determines the degree of dampening. So it's sort of a way you can cheat a tuning of the holder. If you look at vibration between all the different systems, one thing you'll notice is Weldon and hydraulic have very similar profiles when it comes to acceleration or a G factor. So that acceleration shows up as vibration. So if you look at the Centro P system, you have just a little bit more, a little bit less than 0.5 G factor. And then you'll see the magnitude of each peak. So each of these peaks is a flute on your tool. So this is 1, 2, 3, 3 or 4 flutes. Then you compare that to a Weldon. So Weldon here has about 2.5 times its gravity in acceleration. So you have 1, 2, 3, 4. Those peaks are very high in magnitude. Was that nearly 5 times? And then the hydraulic extension, although it has similar run-out precision, or can have similar run-out precision, you also have vibration because there's little dampening between the holder and the actual tool. So controlling this acceleration actually reduces the vibration, preserves the machine and the spindle. So those spindle bearings, every time this gets knocked around, that's putting wear on your machine. And most importantly, preserves the cutting edge. So expensive end mills and those type of tools, precision tools, haven't gotten cheaper over time. So chipping those edges from vibration obviously costs you more money. The other note about the Centro P is the holders are all balanced. They're all fine balanced to G2 at 25,000 or 30,000. Having a nice balanced holder reduces the vibration, damage to the spindle bearings, minor surface quality issues, inadequate dimensional accuracy, shortened life, and most assuredly noise generation. So now having that tool balanced can create a lot of racket in the shop. Also, the Fahrion tool, you can actually insert many tools a lot farther in the holder than some. So this is an example, an RGS type tool for mold making. You can actually envelop the entire tool rather than have it stick out. And we know the alternative to a Fahrion holder is you have 2 tools and you cut off one so that it sits shorter, so you get the proper rigidity. But with the Fahrion system, you can use the same tool and slide it in and out the exact amount of reach that you need, giving you better surfaces and longer tool life. Just as an example, here's a market success. This is comparing sort of apples to apples with the same 4-flute end mill. 1/4 inch, 400 SFM, 6,112 RPM, and a feed of 50 inches a minute. This is an ER, a standard ER chuck, compared to the Centro P. The competitor tool was about $75. The Centro P, when you look at the collet, the chuck, the collet, and the front nut, $279. The torque wrench was $106. But you look at the tool life, parts per edge 1,000, parts per edge 1,700. This resulted in a 70% increase in tool life, utilizing like-for-like cutting data using the same exact type of tool. $51 in tooling costs per tool change. So the Fahrion will pay for itself in 6 tool changes. So now we'll talk about how to apply. Make sure to clean all the mating parts. You don't want to have a 2-micron system and then have a bunch of dirt throw off your accuracy. Make sure to use the proper roller bearing wrench. Don't use a sort of an oil filter wrench or any kind of adjustable wrench. Use the proper system to get the best performance out of the tool. Just like in an ER system, you'll insert the collet into the clamping nut and then into the holder. If you're using a Weldon system, you're using a Weldon tool, make sure that you don't have any of the Weldon protruding from the front of the collet, because when you clamp on it, you could cause some damage to the collet. You can actually distort the internal bore of the collet. Use the proper size collet to match the shank diameter. And most importantly, the Fahrion is not designed to span multiple diameters. So don't use these collets for letter drills or number drills or fractional sizes. Use them for the exact size and pay attention to your tolerance on your shank. Of course, they fit standard tolerance shanks that you'll find on solid carbide tools or drills, but just make sure, don't expect the tool to collapse. Thanks for joining us. Don't forget to attend our live training and hit the subscribe button so you get alerts when we add new videos. Thanks and have a great day.